Dear colleagues, we are now in the modeling methodology workshop in UCL, UK, and I would like to introduce a new scientific discipline, the discipline of modelology. It is essentially a systematic study in models and modeling, as well as model usage. And in my understanding, it is a very important discipline that should be developed. You can ask me why. We have so many different kinds of models we apply everywhere in our life, in sciences, in technology, and in engineering, and also in normal life. For this reason, we have been compiling in a bottom-up manner which models are used in sciences and engineering. For instance, models in archaeology, that is the classical clock of Antikythera, or models of the black hole, or models in physics, or models in environmental research, or models in climate research, or models in medicine, mathematics, in economy. Wherever you want to have some kind of treatment of things that is understandable to humans, we use models. And for this reason, we should now try to analyze what is in reality a model. First of all, we should, however, answer a question. Why do we use models? We use models because we are humans. And we use a little approach for that. We separate things of concern. We concentrate on something. We would like to have a convenient treatment of our environment, our thoughts, our things. And of course we would like to avoid information overflow and anything else. From the other side, we have complex data massives, we have a lot of biases, we have also deep models underneath, we have also hidden aspects and shadows. The origin's complexity might be far beyond our abilities somehow to overlook, to understand it. For this reason, we are using models to represent things. That means we need to have a good understanding of what is a model. The model, in our understanding, is of course a universal tool. We are not so much targeting on a beautiful model, but we are targeting on a model that can be easily understood, that is parsimonic, that is understandable, believable, harmonic and balanced, so that we can handle it for the purposes, for the usage we have in mind. That means in this case, a model is a universal tool, but we should understand what it means. It is essentially an instrument. I have here green and white slides. The green slides will be given in a more detailed manner in a longer video. Furthermore, I will use in most cases only the white slides. Modelology means also we have to separate what is not a model, what is never a model, what is a bad model, and for this reason we need also some kind of separation or distinction between the different kinds of models. That means in this case we come with modelology as the study of models and modeling as well as model usage. That is currently an art or craft, and of course based on a craftsmanship. We answer so far questions like, when does something become a model? Is this something a model forever, or has it a journey? What are the characteristics of a model? What quality is expected from a model? What kind of trust, belief we can have in a model? What characteristics are necessary or maybe excluding a thing to be a model? When a model is suitable, appropriate, what is the potential and capacity of a model? That means in this case we should answer these questions with a, let's say, systematic consideration. What is a model, or what is model being essentially? And then in this case we might have a chance to found this new discipline. My claim is models are everywhere. If you see here the Brown book, unfortunately it is written in German language, we have been analyzing about 40 different disciplines in sciences and engineering and came up with a detailed discussion in about 20 disciplines, and we came up with some kind of architecture, common understanding of a model after this bottom-up analysis, and we found that a model is something that is adequate, dependable, and it is used as an instrument. It represents as such origins and functions in utilization scenario. And for this reason we would like to have some kind of well-formedness at least, so that we can use it easily. Adequateness means it should be analog, focused and useful. Dependable means it should be justified and sufficient. Justification means we should have really an explanation. It should be corroborated. It should also be coherent and conform. It should be verifiable or falsifiable. And of course it should be somehow stable and plastic. Sufficiency means it should have a right, definitive quality for usage of usage. That means in this case we have now a model, or something can become a model if we can say it is adequate and dependable, and it is an instrument. I will now try to consider these properties furthermore. Adequate means first of all it should be analogous, so that we can really represent the essential things, the important things in our origin set in a proper way, and we can somehow use this kind of analogy for reasoning, for using the model in a proper way. That means in this case we can now somehow compare our instrument to the origin. Of course it should be similar, it should be maybe not as detailed as origins are, it should either idealize things, and we can base it on a number of principles. Analogy is, in the sense of Lakoff and Lakatos, the core of our cognition. It is based on a number of properties like mappings and similarity, and of course it is based on the relationship to origins. Furthermore, a model must be focused, so that we can concentrate our attention to the necessary things. There is nothing else as our horses are concentrating on streets with some kind of little helper, so they can not see whatever is around. Focusing is a very nice weapon. We can concentrate, abstract, make sense, but we should not overfocus. Overfocusing would mean that we lose somehow the understanding of the whole thing we would like to represent as an origin. The third thing is it should be useful. It should be good to use, suitable, capable. And of course it should be a little helper and help us in such a way that we can really make some kind of added value of that thing. Let me consider one simple case for the adequacy. So far in computer science, for instance, we are considering building a system by, we have some idea, we try to have some kind of program, some kind of implementation, and then we realize the whole thing and see that this model and this refined model is now represented by some tool. Currently we are, however, a little bit further advanced. We know how to map a model into something that can be somehow mastered in a workshop and then really used for production of our results. In future we will go further. We will have models as a program. That means in this case we have some model. The model is directly mapped to something that can be really mastered, and to something that can be technologically supported. That is the future in computer science, and I think the future in most disciplines which use models. The second line of properties a model must have is dependability. It should be accepted in some way without any serious doubts. It should be reliable. It should be somehow trustworthy. That means in this case we might have now some kind of additional property that is often forgotten and often not explicitly stated, what is however necessary. And it is necessary because of we want to have a reliable, useful way with our models. So in this case, we need to have some kind of dependability. Dependability means, first of all, it should be justified. We should give a reason why the hell we are using that thing as a model. In this case, we can say, okay, fine. Justification means we should have an explanation. We should have a reason to believe in that thing in a proper way. We should have also some kind of coherence, conformity. We should also be able to say, no, this is not yet a model. That means we should have some validation, falsifiability, and we should also have some kind of stability in the sense that we can change our origins in a slight manner, and then the model still will be the model. That means in this case, justification means it should be reliable, credible, stringent, well-grounded, convincing, trustworthy, and we should even be able to state that. The second property of dependability means it should be sufficient in the quality. Classically in quality in use or quality of use or quality for use, it should be somehow, of course, have an added value. And of course, we need now to have some way to evaluate whether it is of a sufficient quality. So that means in this case we have now dependability and adequacy as our main properties for something to become a model. It is adequate and dependable. Furthermore, it is an instrument that is used. Quite often we forget about the instrument function, quite often we forget about dependability, but in reality it is somehow as a hidden or deep or implicit statement, has an implicit statement behind. That means in this case our model must have a good property to be used. Now we can ask the simple question: can we have some kind of unified theory or practice of models? Are all models the same? Of course, everybody will claim directly, no, they are never so unifiable. That is right. Maybe we have to have some kind of classification and then treatment mechanism. And I will introduce one of them. Let's say models are used, first of all, maybe for presentation, but also for practice, but also for cogitation, and what is often forgotten, also for social being, for our being at all. And then we can say, okay, fine, in this case we can use another separation of concern. A model is either a personal model for somebody, or it is or by somebody, it is a community model shared within a community and understood in that community in the same maybe way. We can go further. We can say, okay, a model is given by somebody to somebody. That means we have something like a P2P pattern, or to community, or considered in a community by the community and for the community. So it means in this case we have now maybe 8 different categories, general categories of models. We have perception models, we have representation models, we have activity models, we have guidance models, we have reasoning models, we have sense-making models, and we have maybe orientation models or socialization and interaction models. We can also have a finer distinction. The finer distinction is shown here with a little bit more than 50 different kinds of models. For instance, I am using in computer science quite often a description model describing what is my idea of a system and delivering it to a community. I can have also something like a model to represent my imaginations, or a model to represent whatever is my maybe representation of my personality to the community. That means in this case I have pretty different kinds, but all these are combinable to be adequate and dependable according to the issue, our intention, our reason why we want to use that model. That means in this case we have now maybe a very sophisticated treatment. But now we have still to answer the question how this treatment could be somehow organized. And the organization would be, in this case, what we are proposing, an organization that will separate different things. First of all, we have to clarify what is the nature of a model. What are the origins and what results we will have to reach with our model as an instrument. Then we embed this into a situation. And the situation is nothing else than to say, what is the scenario in which the instrument should function, and what is the brand that is given by whom, on what, in which context, to whom, for what activity or general, let's say, idea making with some kind of added value. That means in this case we specify the landscape into which we are embedding that something that is now becoming a model. And then we have some kind of deep underpinning behind. I would clarify or specify it as a strategy behind. What is the Ansatz? I could also say the methodology or mold. And what is the implicit model behind? That is typically assumed whenever we are handling models and not explicitly stated. And the other thing is the make of the model. What are the supporters? What are the enablers? We can somehow give this configuration of a model within this kind of diamond as a worksheet for configuration. What are the origins? What are the results we are expecting? What kind of scenarios we have so that the model should function there? And what kind of being we have so that the thing is really formed and usable as a model? What is the strategy behind? What is the tactics for using and enabling our model? And what is maybe the model's journey according to what we would like to have. This can be also, let's say, done in a stepwise manner. So we say, okay, fine, the nature is considering these 4 points. The mission is considering or extending the 4 points by whom and why and for what. And the brand is also something like as an extension, the strategy as well. So in this case, we can have a systematic treatment by some kind of a worksheet. Yeah, and we would like to have models that have an added value. They should be useful. That is still a lacuna in research. The modelology, as a study of models and modeling, needs this further research. I have a proposal for this research, and we have been using this proposal for models in computer science and computer engineering. That is, we say the model usage is either to apply, to employ, to operate, or to utilize a model. To employ, for instance, means an agent is under some circumstances, within some context, having or facing some event, and to have to handle this event in a proper way as an instrument in some manner, of course, with having in mind what is the purpose, what is the role, and what is the time being of that model. And of course we have additional somehow ingredients for using this model and for specifying the use of the model. That can be done systematically for all different kinds I have been here showing of models. We did it in this part for archaeology and for Egyptology. In this part you are mostly used to use a model in sciences as a reasoning tool or as a sense-making tool. We are using in engineering a model mainly for developing, for practicing, for as a guidance for an activity. Models are often based on a presentation, and for this reason we have different kinds of usages all the time that we can use here in our framework. That means in this case we have now, if we go for a systematic discipline, nothing else as functions of modelology. These could be separated into model development, model usage, model engineering, model utility, meta-model management, model governance, model reference and model management, model quality management, or in general in model management. That would be somehow branches of our modelology as a discipline. We can use our setting, our configuration we have had here for separating concerns, saying first why we have to use something as a model, what is our intention, what is our thought behind to use something as a model or to accept something as a model. Then in this case we can say, okay, fine, this can be also done in a more systematic manner by setting this specification framework. That means in this case we are representing the model being by some kind of architecture. We have here our strategic part, that is maybe our cellar and fundament of the model house. In general we are considering the model as an instrument representing some origins. Of course the representation and the presentation is based on our wish to have some results through model usage. That means we are using the model in some application scenario or application sphere in more general manner. We have a task space, we have a delivery space, and of course the model has now a profile and of course is used within a portfolio. And to use means in this case we have to have supporting means, we have to have enabling means, we are considering usage in a context, and of course for a community of practice. That means in this case we can now somehow specify what it means. And we get this kind of, let's say, two-phase modelology specification framework. We can have also some kind of anatomy of the model being. We could explain in detail in, let's say, as a longer version of the lecture. I should come to an end after 25 minutes or so. Models are our little helpers. They help us in anything. They help us in understanding a thing, in reasoning about something, in practicing, and also in our social being. That means in this case we have a lot of benefit from our models. And for this reason we should maybe systematically develop modelology. That means in this case we have maybe to found now a discipline of modelology in a proper way. Okay, there are some papers or some publications to consider in this case in order to understand what I have been presenting here in a very, very brief manner. papers from my group or videos. There's a video channel with my name. There are also other video channels I have been using. There are German and English sources. The main book is, of course, this Wissenschaft und Kunst der Modellierung, written in German language, but you have also a good number of videos of a complete course in Modelology. I thank you for the attention. I hope for a very good number of discussions. I have somehow additional slides I have been preparing for discussion, but they are not, let's say, this is not a complete list, whatever we can consider, but whenever we have time for questions, I would like to show you something of results of these sorts. I thank you for the possibility to present here Modelology for very, very different kinds of models we are using everywhere in our life, and I claim even in a far more general manner than only languages. Models are our first instrument and languages come later, and models are our best instrument, and then in this case we should somehow develop a systematic modelology discipline. Thank you.